Hello everyone, welcome to GATE 2026 Score Booster series, where in this series we will discuss numerical answer type questions and multiple select questions, friends. Okay, so these questions mostly related to algorithm subject. Okay, so first let me explain what are the important or high priority topics in algorithm topics. Afterwards I will introduce few questions from this topic, friends. Okay. So generally in algorithm topic, the first section goes to asymptotic notations and time complexities. Asymptotic notations and the second part is called time complexities. We can expect minimum 1 mark and maximum 2 marks from this topic, friends. Okay, so therefore it is the first part of the algorithm subject. Okay, and the second part will goes to divide and conquer. Divide and conquer. Under divide and conquer we need to focus maximum portion is master theorem, because by using master theorem we usually solve many questions. Okay, so one part is master theorem and the second part is sorting algorithms. With respect to sorting algorithms, you need to focus on quicksort and merge sort algorithm, friends. Okay, and apart from quicksort and merge sort, you also focus on finding max and min of array of n elements. Okay, and also just memorize the recurrence equation of, we are having one recurrence equation, matrix multiplication algorithm. Okay, Star's matrix multiplication algorithm. At least you can memorize the recurrence equation, friends. Okay, so apart from that you no need to focus any other topics. Okay, anyway, binary search concept is an application where we are using in insertion sort algorithm and then heap sort algorithm. Okay, therefore you no need to focus directly on binary search algorithm, friends. Okay, next afterwards third part is greedy method. Greedy method. So in greedy method generally we are talking about optimization problems like minimization or maximization. So in greedy method total we are having 7 algorithms. I can say each and every algorithm is important only, like starting from job sequencing, knapsack problem, optimal merge pattern, Huffman coding, and then shortest path algorithm, Dijkstra algorithm, Bellman-Ford algorithm, and then minimum cost spanning tree, Prim's and Kruskal's algorithm. Every part is important, friends. Okay, so I can say highest priority goes to greedy method, because every year in every question paper they are asking at least 1-2 marks question from the spanning tree concept. Okay, so therefore, so greedy method we will discuss those topics. Then next one is dynamic programming. So if you consider dynamic programming, the dynamic programming we are dividing problems into 2 categories. First category is called shortest path algorithms. Like shortest path algorithms we are having multi-stage graph, traveling salesperson problem, and then Floyd-Warshall's algorithm. Floyd-Warshall's algorithm we can also call it as all pair shortest path algorithm. Okay, all pair shortest path algorithm. It is compulsory, at least you have to remember time complexity and the process for all these, friends. Okay, so more frequently asked question in the GATE exam is all pair shortest path algorithm, which is Floyd-Warshall's algorithm. And second part applications like matrix chain multiplication. I can say it is a matrix chain multiplication. Matrix chain multiplication, longest common subsequence problem, and then 0-1 knapsack problem. Okay, so based on previous year question paper analysis, so far in matrix chain analysis they asked 4 questions, friends. Okay, and LCS they asked 2 times. 0-1 knapsack problem they asked 2 times. This 0-1 knapsack problem they usually combined with greedy method knapsack problem and dynamic programming knapsack problem, friends. Okay, so they will combine both the topics, they will ask the question. So apart from these 4 topics you need to focus on graph algorithms like BFS algorithm and then DFS algorithm. Especially in DFS algorithm there are several applications are there. The first application, that is topological ordering. Topological ordering, which is highest priority topic in DFS applications. So far there are 6 questions came from topological ordering in the GATE paper. First one is topological ordering. Okay, now afterwards second one is articulation points. articulation points, bridges and biconnected components. So based on articulation points, we have some theoretical points like how do you identify an articulation point by using DFS algorithm. There are several properties we discussed in the class, like leaf nodes cannot be an articulation point, root node is an articulation point if and only if it is having at least 2 children. So those points are compulsory, you have to remember in order to answer multiple select questions, friends. Okay, so articulation points, biconnected components and then strongly connected components. Okay, apart from that, so topological ordering, articulation points, and another one is called strongly connected components. Strongly connected components, these are application of DFS. Okay, where BFS mainly useful for finding shortest path distance. So this BFS algorithm useful for finding shortest path distance for unweighted graph. Okay, whereas a Dijkstra algorithm, Bellman-Ford algorithm, they are useful for finding shortest path distance in weighted graph, friends. Okay, weighted graphs. So this is a very simple topic. I can say, suppose if the tomorrow is the GATE exam, then I can prefer only 3 topics, friends. Okay, the first topic is called sorting algorithms. Sorting algorithms. Under sorting algorithm, we need to study all comparison based sorting algorithms. Okay, there are 2 types of algorithm: comparison based sorting algorithm and distribution based sorting algorithms. So in your syllabus, you are having only comparison based sorting algorithms, like we can say bubble sort algorithm, selection sort algorithm, insertion sort algorithm, quick sort, merge sort. Afterwards, we are having heap sort. So these sorting algorithms we need to study in elaborate manner by taking different types of input categories, like if array elements are in the ascending order, if array elements are in the descending order, if array elements in the random order. So all kind of varieties of question you need to practice based on sorting algorithms, friends. Okay, not only there are some characteristics for the sorting algorithms like in place sorting algorithm and then stable sorting algorithm, adaptive sorting algorithm. So all these properties you need to remember them. Okay, so nowadays they are focusing on number of comparison and number of swappings. Means in the numerical answer type question, what type of question they are asking? If you see just recent year paper questions, so for example, they are providing array elements in the ascending order like 10, 20, 30, 40 and then 50. So array elements are already in the ascending order. If you apply quicksort algorithm on this array by choosing last element as a pivot element, then how many minimum number of swaps are required? So GATE examination point of view, they are considering swaps are nothing but 2 different elements are exchanging their places, that is considered as a swapping here. Okay, so with respect that how many swappings are required means obviously 0 swappings are required because array is already in the ascending order. So in the numerical answer type question, they will ask in this type of problems, friends. Okay, swappings and number of comparisons. Okay, just verify last 2-3 years GATE papers, you can understand they are providing array of 5 or 6 elements. They are asking how many comparisons are required, how many swappings are required. Okay, so or else they will provide an array in the ascending order, they will provide 3-4 algorithms. They will ask which of the following algorithm is required, minimum number of swappings or minimum number of comparisons, like that. Okay, so let me focus on some of the questions which I collected, numerical answers and multiple select questions based on this topic. Yeah, focus on first problem. This problem related to Dijkstra algorithm. Okay, if you have complete idea about algorithm so that you can easily answer this question, take 1 minute, pass the question and verify whether you are able to answer the question or not. Okay. I will also read simultaneously. Consider a directed graph with V vertices and E edges. There is a directed graph with V vertices and E edges. All edge weights are non-negative. All edge weights are non-negative except for exactly one edge with weight is equals to -2. It means that all edge weights are non-negative. There is only one edge whose weight is equals to -2, friends. Okay, and Dijkstra's algorithm is run from a source vertex S. Okay, and if none of the shortest paths from the source S to any other vertex uses the negative weight edge, it means that from source to destination none of the shortest path uses negative weight edges. So its meaning is, for example, you are having source vertex is S, here we are having X, let it be Y, okay, let it be Z, maybe there are intermediate vertices also available. So from source to reach destination, maybe there are multiple paths are possible. Okay, just imagine like this. Okay, if none of the path is using negative weight edges, then the number of vertices for which the Dijkstra algorithm compute incorrect shortest path distance. Incorrect shortest path distance is, means for how many vertices it can find incorrect distance from the source to the destination. Okay, take 1 minute, pass the question and try to answer the problem, friends. Okay. Yeah, the time is very precious now. Let me explain this topic. See, we are having two algorithms. One is called Dijkstra algorithm. Dijkstra's algorithm. Another algorithm which we are having, that is called Bellman-Ford algorithm. Bellman-Ford algorithm, right, friends? Okay. If you see edge categories, for example, edges, I can see the types of edges, for example. Okay, types of edges. Types of it doesn't mean that back edges, T edges and like that. Okay, here all edges are positive weights. If all edge weights are positive weights, then Dijkstra algorithm computing shortest path correctly and Bellman-Ford algorithm also computing shortest path correctly, friends. Okay, but if some edge weights are negative, okay, some edge weights are negative, and if any destination uses that negative weight edge in the shortest path, then Dijkstra algorithm, there are two possibilities. It may or may not compute, shortest path correctly. Okay, it means that from source to destination, if any destination vertex uses a negative weight edges from the source, then it may or may not compute the shortest path distance, friends. Okay, whereas Bellman-Ford algorithm, it is always computing shortest path distance. Next one, if types of edges, here I am talking about some edges. Okay, some edges are negative weight edges. Okay, suppose if the graph is having negative weight edges and also having negative weight cycle, graph is also having negative weight cycle, So what is the meaning of negative weight cycle? So for example, if I consider source is S and destination is D, assume that they are connected by means of negative weight edges. Let it be 3 and its weight is equal to -5. Right, friends? Suppose if you want to reach from S to D, its cost is something like 3. If you say minimum cost is 3, I can find better minimum by rotating like this. I can come back to here, then 3 minus 5, that equals to -2. Again if I go like that, -2 plus 3, that equals to 1. So minimum is 1. Suppose if you say minimum is 1, again I can go one more round. It means that first you mentioned that shortest path is S to D. Now I am saying that S to D, D to S. Right, friends? Okay, S to D, D to S, S to D, D to S. Means if you are continuously running like that, automatically shortest path distance weight automatically decreases. Therefore, if the graph is having negative weight cycle, then there is no shortest path algorithm is available for finding shortest path distance from source to destination. But how do you determine that whether the graph is having negative weight cycle or not? Means this Bellman-Ford algorithm, return false if the graph is having Bellman-Ford algorithm return false if the graph is having negative weight cycle. Therefore, what are the possible way of asking question from this? Okay, if the graph is having all edge weights are positive, then both Bellman and Dijkstra is giving shortest path correctly. If the graph is having negative weight edges, if any vertex is reachable from the source by means of that negative weight edges, then obviously Dijkstra algorithm may or may not compute shortest path distance. Okay, so Bellman-Ford algorithm always computing. If the graph is having negative weight cycle, in that case no algorithm can compute shortest path distance, and Bellman-Ford algorithm detect the negative weight cycle and it will return false. Okay, in our problem, if none of the shortest path from source to other vertexes uses the negative weight edges, means no destination vertex using negative weight edges from the source, in that case incorrect shortest path distances, it is possible only 0. Okay, they are asking the number of, look at friends, the number of vertices, obviously 0 number of vertices, okay, 0 number of vertices can compute shortest position incorrectly. The reason is the shortest path is not passing through negative weight edges, okay. Next question friends. My explanation is going on, no problem. See, by using one question we are able to discussing all concept. The main objective of this 1 hour session is we want to really recollect all the topics friends, okay. Don't worry about how many questions we covered in the session. Just go through this model. In the recent year gate paper they are asking this type of models, okay. Usually asymptotic notation they are using belong symbol nowadays. That's why you have to practice questions in this way. First option f belongs to order of g, second option f belongs to omega of g, third option f belongs to little o of g, and fourth option f belongs to theta of g. I hope you already gone through this question, okay. Let me explain what is the concept behind this one. See, if f of n is a function and g of n is also function, as our analysis only for large values of n, means as n approaches to infinity you need to find the behavior of f of n and g of n, okay. So therefore as n approaches to infinity we can write it as mathematical limit n tends to infinity. The limit n tends to infinity f of n by g of n ratio we need to find, okay, in order to analyze the growth rate of f of n and g of n for large values of n. So after computing this value, possibilities are it may be less than or equal to c, it may be greater than or equal to c, or it may be equal to c, or it may be less than c, or it may be greater than c. These are the possibilities friends, okay. So here one condition is it should be true for some finite c, not for every, okay, some finite c greater than 0, means the ratio between these two is less than or equal to c, some finite c greater than 0, okay. In that case we can conclude that numerator value f of n is equals to order of denominator value. Numerator function is equal to order of denominator. So mathematically we can also refer this statement as f of n belongs to order of g of n. We are showing like this, okay. Next one, suppose if it is greater than or equal to c, here also we can use some finite c, some finite c greater than 0, if and only if condition f of n is equals to omega of g of n. We can also write in a short format in the form of belong symbol, f of n belongs to omega of g of n. You can remember like that, okay. Suppose if it is equal to c, what type of c? Some finite c, some finite c greater than 0, okay. So then we can write that f of n is equals to theta of g of n. We can also use belong symbol, so f of n belongs to theta of g of n, right friends, okay. As I mentioned, this course objective is to recollect all the basics what we covered. That is the reason for every question I am able to recollecting all basics friends, okay. If less than c, it should be for all finite c, for all finite c greater than 0. Then if and only if f of n is equals to little o of g of n. We can also denote as f of n belongs to little o of g of n. Clear friends, okay. And finally greater than c, it is also for all finite c, for all finite c greater than 0. So if and only if, that is f of n is equals to little omega of little omega of g of n. We can define it as f of n belongs to little omega of g of n. You believe me friends, if you could remember the sequence, you can easily answer any question in asymptotic notation when they ask question with respect to comparison of two functions, okay. Now come back to our problem. So our problem is f of n equal to n log n, g of n equal to n to the power of 1.5. So I clearly explained this type of model in the class also. Whenever you want to compare two polynomial functions, just cancel the common terms. Just cancel the common terms, okay. So therefore, g of n is equals to, we can also write it as n into, okay, n to the power of 1.5 means obviously we can write n into n to the power of 1 by 2, correct? N into n to the power of 1 by 2. Just cancel the common terms, it is n, it is also n. Now we are having it is log n and also it is root n, right friends, okay, log n and root n. So therefore, if you apply f of n is equals to f of n by g of n. Actually in the class we did multiple times this type of models. You know log n growth rate always less than or equal to root n. If you are already having idea like this, okay, log n less than or equal to root n, because multiple times we discuss this problem. Not only log n whole to the power of k automatically less than or equal to root n. Multiple times we discuss. If you are already having that idea, no problem, okay. So otherwise you can apply limit formula, limit n tends to infinity, which equals to limit n tends to infinity. What is the meaning of f of n here? That equal log n, and denominator that equals to root n. So we know that log n value always less than or equal to root n. It means that numerator value is smaller and denominator value is larger, okay. So whenever denominator increases, this value must be related to 0. Is it correct friends, okay? So because as n10, or else you can apply L'Hospital rule also, okay. You can apply L'Hospital rule. As n approach to infinity, if you want to apply L'Hospital rule, just apply L'Hospital rule, which equal limit n tends to infinity. Derivative of log n we can say 1 by n, and derivative of root n 1 by 2 root n. 1 by 2 root n, okay. So just cancel the common terms, which is equals to limit n tends to infinity. So we can cancel the terms, we will have 1 by root n, right friends, okay. Of course 2 is also there constant, we can take 2 by root n. As n approaches to infinity, 2 by root n approaches to 0. So whenever you are getting the value 0, now you can compare with the previous formula which I explained. See here friends, okay. So now we are getting limit n tends to infinity, f of n by g of n is equals to 0 we are getting, right friends, okay. Now we can compare with these 5 possible cases. Is 0 less than or equal to some finite c? 0 less than or equal to some finite c greater than 0? Yes. I can take some finite c, it may be 1 or 2 or 3, anything, right. So therefore this statement is true. They are talking about some finite c, that statement is true. Whenever that statement is true, we can say numerator is equals to order of denominator. We can also write in terms of belong symbol, okay. And next one, 0 greater than or equal to c, greater than or equal to c. What type of c? Some finite c greater than 0. Suppose if you take c equal to 1, c equal to 1, then 0 greater than or equal to 1, which is not true, therefore it is false, okay. It is false. Once it is false, we can say numerator not is equals to omega of g of n, right friends, okay. Next they are talking about c equal to c. Tell me 0 equal to c, 0 equal to c. What is c here? Some finite c greater than 0. Suppose if you take c equal to 1 or c equal to 2, c equal to 3, how 0 equal to 1 or how 0 equal to 2? Is it possible friends? No, right? Therefore it is also false. It is also false. So since it is false, f of n not equals to theta of g of n, right friends, not equal to theta of g of n. Next one, verify 0 less than c, 0 less than c for all finite c greater than 0. Yes, we agree that, because 0 value always less than c for all finite c greater than 0. Therefore less than c, which is correct, okay, less than c, which is true. Once I mentioned is true, we can write that f of n is equals to little o of g of n, little o of g of n, right friends, okay. Next one, it is greater than c, 0 greater than c for all finite c greater than 0, which is false, right, which is false. Therefore from this we can conclude that f of n equal order of g of n and f of n equal little o of g of n. Students who already attended my class, they can easily answer this question without using paper and pen by just analyzing this one. See, it is log n, it is root n. We know that log n less than or equal to root n, right. Whenever denominator value is larger value, automatically it tends to 0. If it tends to 0, obviously numerator equal to order of denominator, right, and automatically omega f of n is equals to little o of g of n also. So answer to this question is A is correct, C also correct. A and C both are correct. Okay. So in the exam, you no need to do all this, okay, because it is like we want to explain all basic concepts and we want to recollect all this. That is not explained, but in the exam we can directly apply the formula, friends. Okay. Yeah. Can you look at this problem? This problem related to heap tree. You have 1 more minute time to complete this problem. I hope you got clear idea of this one, right? It's okay. So consider a max heap containing the elements. So we are having elements 50, 30, 40, right? So let me draw that max heap. So 50 is a root node. You know, max heap is nothing but it is a complete binary tree, and complete binary tree always filling from left to right. Complete binary tree always filling from left to right. Okay. So it is array representation of max heap. So 50 having children are 30, 40. In the exam, this model also asks 2 times in the gate paper. They will provide options A, B, C, D. They will ask question which of the following is valid array representation of max heap. If they ask which of the following is valid array representation of max heap, just you can explain like this. 50 is having children 30 and 40. In max heap it is allowed, because in max heap parent must be greater than children, and 30 greater than 10 and 5, which is also allowed. Then 40 is having children, that is 20, which is also allowed, friends. Okay. So therefore let me draw the heap tree first. 50 children are 30 and 40, and 30 children are 10 and 5. 30 children are 10 and 5. And finally, so 40 is having only one child, that is 20. So the main object of this question is student must understand how to insert element into heap and how to delete an element from the heap. Because in the gate paper previous year gate questions, they ask one time, after performing two delete operations from the given heap, then what is the content? Okay. So that is a model asked in the gate paper, friends. After performing 2 delete operations on the content of the array, then what is the modified content of the array of the heap, right, friends? Okay. So now what did they ask question here? A new element 45 is inserted into the heap. So insertion, how you are performing insertion means, you know, heap tree basically it is a complete binary tree. In complete binary tree, all levels are full except possibly last level filling from left to right. Therefore while you are inserting element also, you have to follow the same condition. Okay. So therefore 45 means you have to insert node left to right position. Therefore this is the place we can insert here, friends. Okay. This is a place we can insert 45, right, because basically heap is a complete binary tree, right. So once you insert the element 45, now we want to verify is the subtree containing this 45 satisfying max heap or not. So how do you verify? So the moment when you insert any element, you have to compare with its parent. You have to compare with its parent. In max heap, parent must be greater than children. But how do you get parent index? So in heap tree, there is one concept here. Suppose if node is x, available at index I, its right child y must be available at index left child z, and then its parent something like w. Okay. So if the node is having index is I, and its parent must be available at index I by 2, okay, I by 2, and z is available at index 2i, and it is available at index 2i plus 1, provided that array index is starting from 1. Generally we are representing starting index is 1. Okay, if array index is starting index is equal to 1, then this formula is valid. Suppose if the mention starting index is equal to 0, we need to take small modification according to the given problem. Okay. So here look at friends, the moment if you know, if you insert any element, you need to compare with its parent. How do you know parent index? Just you can apply this logic. For any node whose index is I, its parent index available at floor of I by 2. So therefore compare the parent, and if they are not maintaining max heap, you can interchange them. Okay, just interchange, that is 45 and then 40, right friends. Okay, again compare 45 against its parent, but it is already satisfying max heap. So therefore after insertion 50, 30, 45 remaining elements are as it is, right friends. Okay, next, what did they ask question? Then the max element is deleted, means after insertion we have to delete max element. This is called heap extract operation. Heap extract operation will take order of log n time. Let me explain the procedure for heap extract operation. So we are having 50, 30 and then 45, 10, 5, 20, and here we are having 40, right friends. Okay, how do you perform heap extract operation? Just remove root node by replacing with the last leaf node. Just remove root node by replace the last leaf node. So therefore we are placing 40 here. As a result of shifting 40 from leaf towards root, then obviously root node does not satisfy heap tree property. Okay, if only root node does not satisfy heap tree property and rest of the subtrees are maintaining heap tree property, then how would I convert that complete binary tree into heap? We can convert complete binary tree into heap by using heapify algorithm. Okay, just apply heapify on root node index friends. Okay, so therefore it is a root node, we can apply, suppose assume that is array representation of heap is A, then you can apply heapify algorithm on root node index 1. How to apply heapify algorithm? Just if you take heapify algorithm on array representation A at index I, but in our problem root node index we are taking it is 1, therefore I am taking in at index 1. Do you know how to apply heapify algorithm? Just you can compare 40 with the left child. Between these two we can hold a largest element. Obviously largest element is 40, that largest element is going to compare with right child. Okay, and between these two largest is 45, then you can interchange 45 and 40. It means that always you have to exchange with the largest element if largest element is not equals to root node. Okay, then again you do the same operation. So 40 is going to compare with 20, largest is 40 only, but here this element already deleted, so it is already the proper order, right friends. Okay, after performing we are having 45, 30, 40, 10, 5, 20, this node already replaced, that is a modified tree. Okay, so what did they ask question? What is the value of the new root after these two operations, right friends. Okay, so therefore new root value is equals to 45. Answer to this question is 45. See, obviously it is taking more time because I am explaining, I am recollecting all basic concepts once again. Okay, I am assuming that I am not wasting your time friends. Okay, just read this problem which is based on job sequencing problem, which is maximization problem. Job sequencing problem which is maximization problem. So verify are you able to getting correct answer or not. So I hope you already completed this problem. Let me explain. See, generally in job sequencing problem or task scheduling problem, there is one important shortcut method you have to understand. Arrange all jobs in the decreasing order of their profits. Okay. So if you arrange all jobs in the decreasing order of their profit, obviously here profit, if you observe, maximum profit goes to T5, right? T5, right friends? If T5 maximum profit is 25 and if the deadline is 3, based on the given condition, I hope you already read the conditions, right? Every task can be completed by using only 1 unit of time and only one CPU is available for processing all jobs, right friends? Okay. And by using that condition, if the deadline is 3, you can take timestamps like starting from 0, 0 to 1, 1 to 2, 2 to 3, 3 to 4, and then what is the maximum deadline here, friends? The maximum deadline is 3. Maximum deadline is 3. I'm introducing most important point. First verify deadlines, friends. Okay. If the maximum deadline is 3, its meaning is you can process only 3 jobs. Okay. You can process only 3 jobs. So therefore, I can directly evaluate the question, say the number of tasks that are left out, during the preparation of an optimal schedule algorithm. Okay. So here maximum deadline is 3 here, maximum deadline is 3. It means only 3 tasks I can process, friends. Okay. If out of total how many tasks, T1 to T6, out of 6 tasks, if you are able to process 3 tasks, automatically remaining 3 tasks are unable to process. Therefore, without touching this question, directly I can say answer is equal to 3. Answer is equal to 3, because they are asking the number of tasks that are left out during the preparation of an optimal schedule algorithm. Generally, psychologically, student psychology point of view, whenever they are asking question like that, they will try to apply the algorithm and they will check what are the tasks are able to processing, and finally they will decide what are the tasks are unable to process. But what I am suggesting, you don't do like that, it will take time consuming process. Very simple logic in remember, identify the maximum deadline is 3. The maximum deadline is 3, of course you can complete only 3 jobs, okay, and remaining 3 jobs you have to left out. I think no need to explain what are the 3 jobs left out, right, because you know the algorithm. Or else let me take only quick explanation. So maximum profit is equals 25, deadline is 3. If deadline is 3, you can process between 2 to 3, friends. Okay, this is a logic which I explained. If the maximum deadline is 3, you can process between 2 to 3. If that slot is not free, then go to 1 to 2 slot. If that slot is also not free, then go to 0 to 1 slot. Here also, if you are unable to process, then leave that job, okay, or leave the task. Afterwards, next maximum profit you have to consider, that is equal to T3. So its profit is 20 and deadline is 3. Deadline is 3 means you are supposed to process the job before reaching 3. So how many ways you can process the job means you are having 3 possible ways. One is 0 to 1 or 1 to 2 time slot, 2 to 3 time slots based on the conditions. Okay, but anyway 2 to 3 time slots already occupied by T5. Therefore, other possibility I can include 1 to 2, friends. Okay, that equal to T3. Right? I can also include 0 to 1. But if I include 0 to 1 time slot, will I get more profit? Next one. So this problem based on 0 and NAPSA problem. Just look at the problem. Try to answer that question. Have you got, friends? Okay. Actually, what is the main object of introducing this question? Nowadays, they are taking 0 and NAPSA problem. 0 and NAPSA problem which we covered in dynamic programming, friends. Okay. So they are taking 0 and NAPSA problem. They are asking to evaluate this problem in 2 different approaches. Like if I evaluate this problem by using greedy method, and if it is produce a solution, something like we can say V greedy, and also solve same problem with respect to 0 and NAPSA problem, which is nothing but optimal algorithm. Dynamic programming is optimal algorithm. So if I consider V optimal, then they are asking difference between these two, friends. Okay, means you have to understand how to solve problem with respect to greedy method and with respect to dynamic programming also. But in this problem they ask only directly dynamic programming 0-1 Knapsack problem, but you need to focus this area also, friends. Okay, so if they ask only 0-1 Knapsack problem, only two possible decisions are there. You no need to draw the table, friends. Okay, directly manual also you can compute this one. Okay, so just you can manually compute and you can get the answer. So knapsack weight is equal to 10. Apply trial and error method, or else you can draw the decision tree also. Each object having two possible decisions. 0-1 means two possible decisions are there, and we are having objects are I1, I2, I3, I4, I5. Each object is having two possible decisions, 0-1 like that. Okay, then if each object is having two possible decisions, how many decisions are possible? So simple, number of decisions for each object is 2 and exponent is number of such objects. Remember that logic, friends. Okay, if each object is having two possible decisions, then always write two possible decisions, and how many such objects are there means exponent must be 5. Exponent value indicates number of such objects, base indicates number of decisions. Okay, number of decisions. Suppose if each object is having 3 decisions, I can say 3 power 5. Base always indicates number of possible decisions and exponent always indicates number of such objects. Okay, so 2 power 5 decisions are possible. 2 power 5 means obviously 32 possible decisions are there. Out of 32 possible decisions you can imagine like this, all are ones. Okay, like that 1 1 1 1 0, like that at the end we will have 0 0 0 0 like this, right? You may also have something like 0 0 0 1 0 like this. Like that we are having 32 possible decisions. Among 32 possible decisions, this decision never possible. The reason is I cannot place all objects into the knapsack. Am I right or wrong? If I place all objects into the knapsack, why should I discuss knapsack problem? Right? Knapsack problem will exist if the sum of the weights of all objects are exceeds the knapsack size. Then we need to take clever decision to get the maximum profit, right? Therefore, keeping all objects inside the knapsack, it is not possible. That's the reason it is not a feasible solution. It is not at all feasible solution. Okay, so remaining all are feasible solutions are there. Okay, among all the feasible solutions, you need to find an optimal feasible solution which will maximize the profit. I can suggest you can go with the trial and error method. You can get the maximum profit, friends. Okay, suppose if you take I2, so because it is a very simple problem only, that's the reason I don't want to extend this topic. You can take suppose I2, I4 and then I5. So which is equal to 4 plus 3 7, 7 plus 2 9. Knapsack capacity is 10. So in 0 knapsack problem there is a possibility that still knapsack contains some space. So therefore knapsack capacity is 9. If I take these 3 objects, we will get profit is 35 and then plus 50, 85 and then plus 40, that equal 125. Or else you can draw the decision tree, you can do the problem, friends. Okay, 125 is the answer for this question. Because only 2 possible decisions, you can easily guess which one is giving maximum profit. Yeah, can you go through this problem? Right. So the time allocated for this question is completed. See, there are 8 files are available and each file contain 10 units. And the algorithm which we are using is called optimum merge pattern algorithm to merge all files into a single file. We have to merge all files into single file with the objective is minimize the total number of record movements, or we can say total cost. That is the objective. But while minimizing the total cost, we need to follow the procedure that, just look at the procedure. This is the procedure they mentioned. At each step, how many files we need to select? Exactly 2 files. Our objective is minimize the total cost. to minimize the total cost, what are the constraints they provided means at each step exactly 2 files are to be merged, right friends, okay. After merging, how do you know that number of movements or the total cost? After merging, the total cost is the cost of merging 2 files is equal to the sum of their sizes, okay. The merged file can again be merged into or merged with the other files. That's all. These are conditions, friends, okay. They are conditions. And final objective is to find minimum total cost. That is a final objective. While finding minimum total cost, you need to follow the constraints. At each step, select only 2 files and merge, and sum of the total record or total units is equals to merge cost, right friends. After getting resultant merge cost file, that must be merged with remaining files also, okay, right friends, okay. Let me continue this one. We are having 8 files, so therefore I am taking 8 files. Right, there are 8 files. Optimal merge pattern algorithm says that at each step select 2 files which are having least number of records and merge them into single file. But here all files are having same number of records, right? So therefore you can merge these 2 files. We will get one intermediate file. Sum of these 2 units is equals to total cost assigned here, that equal 20. Earlier we had 8 files. Now how many files in your hand? Like we have 1, 2, 3, 4, 5, 6, 7. Only 7 files are there. Only 7 files. But we know that every step we need to select 2 files which are having least number of units or least number of records. So therefore I can select these 2 files again. We can merge them into single file, that equal 20 record or 20 record movements or 20 units. Then total number of files we are having 1, 2, 3, 4, 5, 6 files are there. Select 2 files which are having least number of units or least number of records. I can take these 2 files, 10 plus 10, that equal 20. Now number of files are 1, 2, 3, 4, 5 files are there. Again select 2 files which are having least number of units. So select these 2 files and merge them into single file. Initially we had 8 files. Now how many files in your hand? Only 4 files. It is first file, second file, third file, fourth file. Now select 2 files which are having least number of records, but all files are having same number of records only. No problem. We can merge these 2 files into single file, and number of movements are 40. Now how many files in your hand? 1, 2, 3 files are there. Every step select 2 files which are having least number of records or least number of units. I can merge these 2 files, friends, okay, that equal to 40. When I started in the beginning, 8 files are there. At this level we have only 4 files. Now at this level I have only 2 files, 40 and 40. Then merge them into single file. We will get merging file, like it is not visible, I know. So 40 plus 40, 80. Now in this entire process, what is the minimum cost or optimal cost? Optimal cost means simply sum up all these values. So 20, 20, 20, how many times? 4 times 80, and again 40 plus 40, 80, and then 80. So total, this is 80 and this part is 80, this part is 80. 3 times of 80, we can say 240 is the answer. Okay, 240 is the answer. That is optimal merge pattern. Is it clear, friends? Okay. I am trying to cover more number of concepts within the given time, friends. Okay. Yeah. This is Huffman encoding problem. Okay. Just go through this problem. Yeah, it is same as optimal merge pattern algorithm. It is same as optimal merge pattern algorithm. What you will to do, you can select symbols. Okay, so while performing Huffman encoding, what are the requirements means we must have symbol, and along with that symbol we must have frequencies. In Huffman encoding, it says that symbols must be arranged in the ascending order or increasing order of their frequencies. Okay, if you are in the increasing order of their frequencies, obviously they are already in the increasing order. It is 5, 9, like that, everything in the increasing order, right? Then each iteration select 2 letters which are having least frequencies and then construct binary tree, by assigning first least frequency letter as left child and second least frequency letter as a right child. You can continue that process until the whole tree get constructed. Okay, so just refer our class notes and go through this problem. You can understand what is the, actually here they are asking maximum possible code word length. Do you know what is the meaning of maximum possible code word length? After constructing binary tree, for example, you constructed binary tree, let us assume that just assume that you construct binary tree like that. Okay, so they are asking maximum possible code word. For example, you take maximum possible length of code word means you can take maximum possible height from root to leaf node. So maximum possible length from root to leaf node means like 1 and then 2 and then 3, or else I can take 1, 2 and then 3 like this. Okay, so in that case I can say maximum code word length is 3. So first you need to construct binary tree. After constructing binary tree, verify what is the height of that binary tree. That height of the binary tree, suppose height of the binary tree means number of edges from the root to leaf in the longest path. Okay, number of edges from the root to leaf in the longest path. So number of edges, if I consider here 1, 2, 3, then I can say the code word length is equal to 3. Okay, I am not saying that the answer for this question is 3, just I am explaining the procedure, friends. Okay, so I think you can do by yourself because we have only another 3-4 minutes time. So you can try this problem, just take snapshot. I will show the remaining problems also, you can go through them. Yeah, this question based on Prim's algorithm, take snapshot and verify. Please take snapshot. This indicates that there is an edge from 1 to 2 whose weight is equal to 4. There is an edge from 1 to 3 whose weight is equal to 1. Like that, there is an edge from 3 to 4 whose weight is equal to 3. Take a snapshot and you can do practice. If you have any doubts, you can mail to me or you can WhatsApp to me. In this problem, they are asking the total weight of the minimum cost spanning tree. Okay. This is also very interesting. MSQ question. Consider the undirected weighted graph with the edges, and which of the following edges must be included in every MST. So it is MST means generally we can use Prim's algorithm or Kruskal's algorithm. You can take Kruskal's algorithm, that is best idea. You can easily solve the problem. Okay. So it is an MSQ question. Maybe they may not ask such a easy question in the exam, but I'm giving the pattern of asking question, friends. Okay. So according to Kruskal's algorithm, suppose here total we are having how many edges? 5 edges are there. You can draw the diagram with 5 edges. Let us consider A, B, C, D. I agree that they don't give this as such a easy question, but at least you need to understand the pattern of asking question, friends. Okay. So A to B whose weight is equals to 1, B to C whose weight is equals to 2, and then A to C whose weight is 3, right, and C to D whose weight is 4, and B to D whose weight is 5. That's all. B to D whose weight is 5. Right, friends. Okay. So verify, did I draw the properly or not? A to B, and then B to C, and A to C, next C to D, afterwards B to D. Now apply Kruskal's algorithm. The first point is, if the graph is having V number of vertices, then spanning tree must contain V minus 1 number of edges. The spanning tree must contain V minus 1 number of edges. In this problem, total number of vertices are 4. Therefore, spanning tree must contain 4 minus 1, 3 edges must be required, 3 edges. Then how do I include those 3 edges? I can apply Prim's algorithm. Prim's algorithm always including edges in the non-decreasing order of their weights. Therefore, first I can include non-decreasing order means I can include 1, afterwards I can include 2, but 3 is forming cycle. spanning tree do not entertain cycles and also do not contain disconnectivity in the spanning tree, friends. Okay, so therefore after 1 and 2, next one is minimum is 4. So therefore AB included, BC included, and CD also included. Okay, maybe in the exam they may not ask only these 3-4 edges. In the exam they may ask 6 edges combinations. Okay, so therefore you have to practice them. So AB is correct, AB is included, BC also included, right, friends. Okay, and AC also included. No, AC is not included because it is forming cycle. I can say DC or CD is included. Okay, here I have taken only 4 vertices graph. Maybe in the exam they may ask 10 vertices graph also. Okay, you need to practice them. Yes. Here we need to add one more point, like and this question based on Dijkstra algorithm. Yeah, this problem, consider a graph with V vertices and no negative weight edges, sorry, no negative weight cycle. So already explained, if the graph is having negative weight cycle, we cannot find shortest path distance. Okay, which are the following statements about the Bellman-Ford algorithm are true? You know that Bellman-Ford algorithm exactly running V minus 1 times for every edge. Okay, so therefore that is called relaxation. Okay, so we are calling relax code. Just recall Bellman-Ford algorithm. In Bellman-Ford algorithm, we are calling a function is called relax u comma v comma w. How many times you are calling? For each edge you need to call this one. For each edge we need to call this one, and like that how many times you have to call means you have to call v minus 1 times. Okay, so for example, your Bellman-Ford algorithm is running like this: for I equal to 1 to g dot v minus 1. So it means that g dot v means it is a structure name and it is a variable, g is a variable and v is a member. So to access members of the structure we are using dot operator, friends. Okay, therefore for I equal to 1 to g dot v, it means that this is running how many times? V minus 1 times it is running. It is running v minus 1 times. Every time we have to take each edge. For each edge u comma v, you have to call relax algorithm. Relax of u comma v comma w. Clear, friends? Okay, so therefore v minus 1 times each edge get relaxed. Okay, but look at the statement here. It relaxes all edges exactly v minus 1 times. Yes, I agree that, but every time we cannot give guarantee that they are getting updated. Okay, generally internal meaning of relaxation is nothing but after calling function it must update the cost also, then only it is called relaxation generally. So for clarity purpose I have written here. So I agree that it is v minus 1 times it is relaxing, but every time and update them, this may not be correct, right? It is calling relax algorithm v minus 1 times for every edge, but every time it is updating them. No, it is not possible. Therefore it is not correct answer. Okay, it just calling only relax code, but updating weights or depends on the graph structure only. Okay, so sometimes we can update, sometimes we may not update. We already discussed this question in the class also. Okay, it can detect negative weight cycle. Yes, Bellman-Ford algorithm always detect negative weight cycle, and it return false if it return false if one exists. Okay, if any negative weight cycle exists, it will return false. Next, it works correctly for graph with negative edges. Yes, negative edges, okay, no problem. Okay, without forming any negative weight cycle. It works correctly for graphs with negative edges which are not forming cycle, which are not forming negative weight cycle, So because here I already mentioned this point, friends. Okay, that is the reason I didn't mention again in the options. In the question itself I mentioned that point. Okay, so therefore, So it can detect negative edge cycle, it works correctly even the graph is having negative edges with no negative edge cycle, right friends, okay. Next one, it is faster than Dijkstra algorithm for dense graphs. It is faster than Dijkstra algorithm for dense graph. What is the meaning of dense graph friends, okay. Dense graph is nothing but number of edges must be is equal to square of the vertices. So number of edges is equals to square of the vertices, that is called dense graph, okay. For dense graph they are asking it is faster than Dijkstra algorithm for dense graph. Let me justify this one. If you take Bellman-Ford algorithm, that a dense graph, sparse graph you might have studied in basics of graphs, okay, basics of graph in graph theory. So in Bellman-Ford algorithm time complexity is equals to, we know that time complexity of Bellman-Ford algorithm order of V into E, order of E into E, whereas a Dijkstra algorithm time complexity, there are multiple time complexities are available. According to our standard algorithm, we are having time complexity order of V plus E into log V. This is standard algorithm we are having, right friends, okay. V. So since the graph is dense graph, in dense graph the condition is number of vertices, the condition is number of edges in the graph must be equal to number of vertices square, that is the condition. Therefore in the place of E you can replace with V square. So order of V into V square. Do you know why did I select this question? In GATE 2012 paper they asked time complexity of Bellman-Ford algorithm for complete graph. Time complexity of Bellman-Ford algorithm for complete graph. There they asked complete graph. That is the reason the same model question I have taken dense graph. Okay. So therefore you can multiply here order of V to the power of 3 like this. This is a time complexity for dense graph. Whereas in this case, suppose if you replace E by V square, then order of V plus E is nothing but V square friends, okay, V square, and then it is log V. So obviously when comparing to V square, V is negligible, right, when compared to V square, V is negligible. So you always giving dominating function only, right. So therefore which is nothing but order of V square into log V, V square into log V. Now compare V square into log V into V cube. So just observe it is V cube, that is V square into log V. So for understanding purpose, if I write this one as order of V square into V, suppose if I write like this, obviously here it is V square, here also V square, we can cancel both of them. Means how do you compare two polynomial function? We can compare two polynomial function by cancelling common terms, right. Therefore I am cancelling common terms, V square here. It is log V, it is V. Obviously log V is having lower growth rate when comparing to V. So who is having better performance? Dijkstra algorithm is having better performance even though graph is dense graph, okay, better performance, it is having least time, okay. So therefore the statement it is faster than Dijkstra algorithm for dense graph, which is not correct, okay. So therefore it works correctly for graphs with negative edges which are not having negative edge cycle, correct. It can detect negative edge cycle, yes, it is correct. This statement, okay, this statement we have to write properly friends. It relax all edges exactly V minus 1 times and updating every time, which is not correct. Sometimes it may update, sometimes may not be updated, okay. So this is a question we need to remember. I think time is over. So if anybody interested, you can copy this one, you can practice for multi-stage graph. This is a question I prepared multi-stage graph because so far they didn't ask any question multi-stage graph, okay. It is untapped area. Maybe this time if they ask multi-stage graph, okay, so there is a possibility because untapped area from 1987 to up to 2025 paper they didn't ask any question multi-stage graph. That's why I gave one problem. You just practice the multi-stage graph friends, okay. Multi-stage graph, they are asking using the multi-stage graph dynamic programming algorithm, the minimum cost of from S to T is they are asking, okay. Take snapshot and you can practice it. This is the algorithm we already covered, no need to discuss, that's all, okay. Thank you for giving the opportunity. I wish you all the best and we wish you very happy new year to one and all friends, okay. Thank you.